All right, welcome. We are looking in Khan Academy under Algebra 1, and we're in the unit Quadratics Multiplying and Factoring. This skill is called Difference of Squares. It's slightly more complex than the intro. So what I've done here is written out steps that you should follow whenever you're faced with a quadratic that you're asked to factor or that you need to factor as part of a solution to a more complex problem. The first thing you should always do is look for the greatest common factor. If there's a common factor for both terms or for all of the terms in your quadratic expression, then you can factor that out first, and it will make all of the terms in that quadratic simpler, smaller coefficients, lower exponents, that sort of thing. So that's the first step always. And then, well, almost always, you can always do the quadratic formula, which we haven't come to yet in this series of learning, but at some point, when you have the quadratic formula at your disposal, you really don't have to do any of these first three steps once you have the quadratic formula. Although, if you get used to doing these first three steps, they can get you the answer quicker than the quadratic formula can. They're more efficient if you recognize patterns in what you're seeing. So it's worth learning this because it will actually make it simpler for you to do quite a lot of problems. But the quadratic formula does always work without having to take the first three steps here. But we haven't come to that, so we're going to look at it here. We're going to take out the greatest common factor if there are any, is any. Then we're going to look for special cases. Do we see a difference of squares? Do we see a perfect square trinomial? Those two cases have a pattern that's easy to factor from. And then if there's not that, then there's factoring by grouping or by logic with guessing and checking, which is a perfectly acceptable approach in mathematics. It's not shooting in the dark, it's thinking through what you have and making rational guesses from a list of possibilities that you know to be possibilities because they make sense. Okay, so here we are. Factor out the greatest common factor. So we look at these terms. This is a difference of squares. I mean, it told us that in the title. So we know we're going to land on number 2 here. But before we get there, we can't do the difference of squares yet because 28 isn't a square number. And 7x squared isn't a square number because 7 is prime. But 7 is a factor of 28, and it's a factor of 7x squared. So we can factor out that greatest common factor, like so. 7, this is just using the distributive property. 7 times 4 gives us 28. 7 times negative x squared gives us negative 7x squared. So we have now done step 1, factored out the greatest common factor, and we look in the parentheses and we see, oh, that's a difference of 2 square terms. 4 is a square term, x squared is a square term, so now we can come to our solution, which is 7. This is a difference of squares, so we go to step 2, we look for special cases, there's a difference of squares, and we know the pattern for that is the square root of the first term plus the square root of the second term times the square root of the first term minus the square root of the second term. If you were to multiply that all out, you get 2 times 2 is 4, 2 times negative x is negative 2x, plus x times 2 is 2x. Well, 2x minus 2x is 0, so they cancel out, and then you have x times negative x, which is negative x squared. All times 7 gets you back to the beginning, and we can put our answer in. So, 7x plus 2 times x minus 2. Uh-oh, what did I do wrong? Oh, I said the right stuff, look. See, I was being hasty. It's a good lesson for us. That happens, as you can see, happens to me when I'm being too fast about my work and not thinking through it. I got the right answer. I even wrote the right answer on the screen in my handwriting, but it's a computer. It doesn't care whether I wrote the right answer in my handwriting or if I had it in my head correctly. If I go into the solution box and I type in the answer, that's the only thing the computer is going to look at, and it doesn't have much grace for mistakes. So we need to, it matters what order it is. Look at what happens. We'll take advantage of this. If we do x plus 2 times x minus 2, we do get x squared from that. That's x squared. X times negative 2 is negative 2x. That's that times that. And 2 times x is positive 2x. So far, so good. But 2 times negative 2 is negative 4. Okay? So, problem is, this stuff cancels out just like it did the other way when we had the 2 and the x flip-flop from each other. But look, now I've got a positive x squared minus 4. Well, that's not what I said I needed to have. I needed to have 4 minus x squared. I had to reverse the order of that subtraction, and it matters. If I take 3 and put it in for x here, it'd be 4 minus 9, which is a negative number. But if I put 3 in for x here, it's 9 minus 4, which is a positive number. So it matters what order you put that in. Okay, fair enough. We'll fix that mistake. Two plus x times 2 minus x. Check our solution. There, we got it right. Okay, no big deal. You just move on, learn from your mistake. We'll be more careful next time. Here we go. All right, 81 minus 4x squared. So, first thing we do, we look for a common factor, any common factors. So 81 is 9 times 9. Negative 4x squared, that's 2x times 2x. This is an even number, that's an odd number. 9s are made of 3s, right? So 3 times 3 is 9. So 81 is 3 to the 4th. 4 is 2 squared, so there's no common factor. There are an x only in one term, not in the other. There are 2's in this term, but not in the other. There are 3's that are factors of this term, but not of that one. And so we've got no great common factor, so we're ready to go. This is a difference of squares, right? We have a subtraction, which means we're finding a difference. We've got two square numbers, 9 times 9, 2x times 2x, so we're ready to go with our difference of squares. Square root of the first term is 9, plus the square root of the second term is 2x. Square root of the first term is 9, minus the square root of the second term, which is 2x. And we're good. All right. Again, first step, look for the greatest common factor. I see that my numbers, my coefficient here is 2, and the second number is not a square number yet, but it is divisible by 2, so I can factor out 2. 2 times x squared gives me 2x squared. 2 times negative 81 gives me negative 162. And now I look in the parentheses and I look, do I have a difference of squares? Yes, I do. X times x is x squared. 9 times 9 is 81. So I'm ready to go. This will be 2 times the square root of the first term, x, plus the square root of the second term, times the square root of the first term, x, minus the square root of the second term, 9, and we're good. This time, I really do want my variable first, and I want to subtract the constant. So, okay, in our second factor. So this is 2 times x plus 9 times x minus 9. And let's just, for funsies, make sure I said what I wanted to. 2, yep, x plus 9, and then x minus 9. That's what I want. And we'll go to the last one. Here we go. Looking for any common factors. That's always the first check. 16 is 2 to the 4th, so there are only factors. The only factors of 16 are the prime numbers 2 repeatedly. 81 again is 3 to the 4th, so there's no 2's that are a factor there, so I have nothing to take the common factor out. I look for, is this a difference of squares? It's a difference. The first number, or the first term, is square. That's 4 times x times 4 times x. And then the second one is 9 times 9. So we're ready to go. We do the square root of the first term, 4x, plus the square root of the second term, times square root of the first term, minus the square root of the second term. And we're done.